So hello friends, in this video we are going to discuss an example on Fermi-Dirac statistics. So according to the example, let us assume a p-type semiconductor. So if it is a p-type semiconductor, and let us assume that it has a acceptor concentration of Na1, and for that it has a Fermi level of EFP1. Now this acceptor concentration Na1 has been increased to 10 Na1. Now if the Fermi level position for this 10 Na1 acceptor concentration is EFP2, so let us find what will be the value of this EFP2. And we know that at room temperature the Kt value is equals to 0.03 electron volt. So as we know that in a p-type semiconductor, Na1, that is the acceptor concentration, can be written as Nv exponential minus Ef minus Ev divided by Kt. So for the Na1, the Fermi level position is at EFP1. Similarly, for 10 Na1, we can write it as Nv exponential minus EFP2 minus Ev divided by Kt. So let us name these two equations as equation number 1 and equation number 2. So if I divide equation in A1 by equation 2, then we can find that Na1 divided by 10 of Na1 is equals to Nv exponential minus EFP1 minus Ev divided by Kt. So here will be also in the denominator the equation 2, EFP2 minus Ev divided by Kt. Now this Na1 will cut down with this Na1, and this Nv will be cut down with this Nv. So we will get 1 by 10 is equals to exponential minus EFP1 minus Ev divided by Kt, and it will be plus EF P2 minus EV divided by KT. By simplification, we can see it as minus EF P1 divided by KT minus EV divided by KT plus E Fp2 divided by KT minus EV divided by KT. Hence, we can write 1 by 10 is equals to exponential minus EFP1 plus EV minus EFP2 plus EV divided by KT. So, from this equation we get 1 by 10 is equals to exponential minus EF P1 plus EV plus EF P2 minus EV divided by KT. So, this EV will cancel out with this EV, hence we will get exponential third bracket minus EF P1 plus E F P2 divided by KT, which can be written as exponential EFP2 minus EFP1 divided by KT. So, ultimately, after simplification, we have the KT value. We know that it is 0.03 electron volt at room temperature. So, if we put this value, then we can get 1 by 10 is equals to exponential minus EF1 plus EF2 0.03. So, from this equation we can calculate directly the value of EF2 minus EF1, that is equals to 0.03 ln 1 by 10. So, if we find the value of 0.03 ln 1 by 10, it will be minus 0.069 electron volt. That means when the acceptor concentration has been changed to 10 Na, then the EFP2 position has been changed to EFP2 minus EFP1 as minus 0.069 electron volt. So, this is the new position of the Fermi level for the change of acceptor concentration. So, let us put this information in the p type semiconductor. So you can see that the value of the shift is negative because it is moving in the downward motion. So this is all about this example. Thank you.